Alright guys, this is the last review video for the course. Isn't that crazy? Okay, so on the first one, you were just using the sketch to describe which conic was given. So in A, let's see, when A goes through the side and comes out the bottom, you create a shape that looks like this from the side, and that is a parabola. So that's when it goes through the side and out the bottom. And it could also do it on this cone. Okay, for B, you go in through one of the cone's bases and you come out the other one. That's going to create two parts that has a top and a bottom. That's a hyperbola. In C, we have that cut that goes straight across one cone and it's parallel to the base. That would make a perfect circle. Sorry, if you look at it from the top, it's a perfect circle. So that one's a circle. So it goes straight across and parallel to the bottom, you create a circle. And then the one that goes through the cone, through both sides of the cone, but is at a slant, that's the one that creates an ellipse, which is D. Make sure you go through those, make sure you know them. Okay, so let's start with the equations for a circle. First of all, remember your general form for a circle. If it was centered at the origin, it would just be x squared plus y squared equals r squared. If it has been moved, remember then you have this minus h, and this plus k. I'm sorry, minus h and minus k. And then it's equal to r squared. So this is just if you have a center that's something other than the origin. Okay, so let's take a look. All right, in this first one, we have no change happening to the x, so the center value for the x is still 0, but we do have a change to the y. Remember, it's the opposite, so if it looks like y minus 2, that was actually a positive 2, so the center is at 0, 2. Okay? And then I need the radius, so the radius is this guy square, or that guy is the radius squared, so r squared equals 5, so r equals 5. So then if I want to graph this, I'm just going to graph my center, 0, oops, I just realized I graphed 2, 0, not 0, 2. So I'm going to graph 0, 2, and I'm going to go out 5 in both directions for the y, or for the x, and then I'm going to go up 1, 2, 3, 4, 5, and down 1, 2, 3, 4, 5. And then if I can just connect these as smooth as possible, there's my circle. Okay, let's try B. First of all, the center for B, I do have a change on x. Since it's a positive 3, it's actually negative 3, left 3. And then a minus 4 is actually a positive 4. And then again, 9 equals r squared. So r is 3. So I'm going to graph negative 3, positive 4. And then I'm just going to go out 3 in all 4 directions. And then I can connect that guy. So there's my circle. Okay. All right, on 3, the circles are given in standard form, this is analytic form on this previous page, and this allows you to see the center and the radius. And so we want to find the center and the radius by completing the square and putting it in analytical form. Okay, so the first thing we need to do is group the x stuff and then the y stuff together. And if we had any extra stuff, we would take it to the other side. So remember, completing the square, to complete the square, this would become the squared quantity x, and then you take half of that coefficient, minus 4. And then remember, if we actually multiply this out, we would have snuck in a 4 squared. So there's technically a plus 16 that we snuck in there, right? And so if I technically snuck in a plus 16 on the left-hand side, then I need to sneak in a plus 16 over here to compensate. So once again, it became x minus, I took half of that, so minus 4, the quantity squared, and then I took 4 squared to get that I had to add 16. Okay, let's do the same thing by completing the y's. Y's would become y, half of 6 is plus 3, and then 3 squared would mean I have to compensate by adding 9. So this side becomes 25, and so now we can see our center is positive 4, negative 3, and our radius is 5, because remember this is r squared, so I just squared it. Okay, let's do B. So in B, same thing. I'm going to start by I'm going to get all the x's together, x terms together, so plus 10x, and then the y terms together. And then I'm going to take this guy to the other side, which I would have to subtract. So right now there's negative 5 over there, but we'll see what happens. let's complete the square. This guy becomes x half of this plus 5. And then to compensate, I have to add 5 squared to this side, so 25. To complete the y, I have to do y half of this minus 6, because if it's negative, half of that's still negative. And then 6 squared would be adding 36. So when I add negative 5, positive 25, and positive 36, I end up with 56. So for this one, the center is at negative 5, positive 6, and the radius is square root of 56, which, let's see if we can take out any perfect square factors. I'd probably try 4 first, and 4 works. So this splits into root 4 times 14, or 2 root 14. Okay? Oops. Okay, so these are different. So I said pay close attention to these because you can still find this, but you have to think about it a little bit harder. Okay, given the information below, find the equation for each circle. So these are circles. So we have a center and we have a point. So if you wanted, you could do a quick sketch. So I've got, let's see, negative 4, positive 8. Okay, so there's my center, and then a point on my circle. So this means that my circle is like out here like that, right? See, there's the... So if I want to find the equation for a circle, I need the center, which I have, and I need the radius. That's it. If I have both of those things, I can go. In fact, I can start writing my circle. If I have the center, I can start this part right now. Since the center is negative 4 for the x, that'd be x plus 4, the quantity squared. And since the center is 8 for the y, it'd be y minus 8, the quantity squared. The only thing you're missing is the radius. So the way that we get the radius is the distance. Whoa. The radius is the distance between the point C, the center, and that point we found. So we have to go back to distance formula. I will give you the formula for this on the final and the quiz, but the formula for distance, remember, you have to do square root of change in x squared plus change in y squared. That's the distance formula. It's been a little bit for some of you. So how much do I change in the x direction? Well, I was over here at negative 4, and I went over to positive 3. So from negative 4 to 3 would be an x value of 7. Remember, this is basically Pythagorean theorem. So that's side 7. My y change, I went from a height of 1 to a height of 8. So that side is also 7. So plus 7 squared. Okay, and so we end up with square root of, let's see, 49 plus 49, so square root of 98. Now here's the cool thing. That's the radius, right? Right there, the distance from the center to a point. But remember, your equation is radius squared, and so if this is the radius, the distance, and we're going to square it anyway, you don't need to simplify that. You're about to square it. Square root of something squared is just 98. So my radius ended up being root 98. But then I squared it, so I didn't really need to simplify it because I was going to square it anyway. Okay, endpoints of the diameter. So if, again, I'll do a quick sketch. So 1, 2, 1, 2, 3, 4, 5, and negative 3, 4. Okay. So this is the diameter of the circle. So if first to find the center, I need to find that perfect midpoint. So that's the first thing I need to do. If I can find the midpoint for these, then that would be the center. So remember, midpoint is when I add them and divide by 2. Add the y's and divide by 2. So I get negative 1/2 and 9/2, which is negative, well, you could leave it 9/2, I guess. Depends if you want to make it a fraction now. So this one, I probably would just use the decimals, so negative 0.5 and 4.5. So that's the center, because that's the perfect midpoint. So you can start your circle, x plus 0.5 squared plus y minus 4.5 squared. And then to get the radius, you'd have to find, now this one's going to take a little work. I'd have to find the distance from the center to one of these points. It doesn't matter which one. I'm going to go ahead and find the distance here to 2, 5. So I'm going to find the distance from there. So remember, the distance is the change in x squared plus the change in y squared. So let's see. To go from the center, which is negative 0.5 for x, to this x value, this point, 2, 5, let's see. Negative 0.5 to 2 would be 2.5, so I'm going to do 2.5 squared. The change in y, I'm at 4.5 in the center, and then I go to 5 on the end, so that's only a difference of 0.5. So 0.5 squared. Again, I'm finding the distance between those 2 points. And so I end up with, let's see, I'm going to use my calculator for this because it's going to be a little weird. So 2.5 squared plus 0.5 squared. So it comes out to 6.5. But then remember, this distance is the radius. And remember, we're going to square it anyway when we put it in here. So if I do this squared, I just get 6.5. Look at those carefully distance formula. Gotta remember how to do it. Okay. Moving on to ellipses. So remember that in general, ellipses have the formula, x squared plus y squared over, one of them is going to be a squared, one of them is going to be b squared. The larger denominator is always a, wherever that is. If it's under x, then it goes with the x, but whatever one is larger is always the a squared. Okay. Okay, so we've got the equation. So I guess, sorry, we don't need to do the equation here. We've got the equation. We need to decide if we think this is we want to graph it and we want to talk about these things I want here. Okay, so first of all, we need to find my center. My center, since I haven't changed the x's or the y's at all, would still be at 0, 0. So I'm going to graph that center. It's that easy. It's just like a circle. So the center didn't move. Okay. Then I would list what A and B are. A would go with 36, but remember that's a squared, so the square root of that gives me A is 6, and the square root of B squared would give me 5. So again, the larger denominator is always A squared. So now, orientation, this is like, is it longer horizontally or vertically? Well, because the larger number's under the Y, it's going to be larger in the vertical direction, meaning it's going to have a longer vertical length, okay? So I'm going to go my A value from the center, so that would take me up 6 and down 6 from the center. And then I'm going to go left and right 5 because I'm going to go in the x direction. Okay, and then I can connect these. All right, and then it wants me to list the vertices. The vertices are the longest direction, so I went 6 up and down. So my vertices are 0, positive 6, and 0, negative 6. If you have the graph, you can just count. But remember, we were adding and subtracting 6 to the y value because that was under the y. And we were doing the 5 to the x value. So I'm adding and subtracting 5 to the x value of the center, which gave me 5, 0, and negative 5, 0. But again, you could get those from your graph. Now the foci, the way that I get C is by using the relationship a squared equals b squared plus c squared. So let's see what we got. A squared is 36, b squared is 25. We've got to solve for c squared. So if we subtract this, we get 11 equals c squared, c equals 11. So this is a nasty number. That's okay. Remember that c always goes in the same direction as your vertices. So if my longest axis is happening in the y direction, then the foci should also happen to the y value. So whatever direction your longest is, that's where the focus should go. So I would go root 11. So, and that's happening in the y direction, so you're going to add that to the y value of the center. So I'm going to go 0, and then plus root 11, and then 0 minus root 11. It's nice that my center was 0, 0 because I didn't have to have another number in there. So once again, A was 6, so I went A in this direction and down. Then I went B in the x direction because it was with the x. And then C should also be in the same direction as A. Okay, major axis. I didn't ask this here, but just to remind you, major axis is from vertex to vertex. The vertex are the most important, right? They're the longest. So like since A was 6, my major axis had a length of 12. And my minor axis would be from co-vertex to co-vertex, which would be 5 and 5, so 10. Okay, let's try another one. In the next one, I did not make the center 0, 0, so check it out. So we don't need that again, sorry. I made the center, let's get the center filled in, negative 5, 3. So let's graph that, negative 5, 3. Graph, graph, graph. Remember, I asked you to graph so you would get points for graphing. So I would start there, And then I would finish the graph. Okay, so A is the denominator for this, a squared is 16. Remember, the bigger one is always a squared. So if that's a squared, a is 4. And if this is b squared, b is 2. What's the orientation? Well, since x is bigger, it's going to be longer horizontally. This is horizontal. So my a value should go in the x direction. So a is 4, so I'm going to go 4 to the left, 4 to the right. And then I'm going to go my b value in the y direction. So 2, 2. Again, the easiest way to remember that is if it's under the x, you should be going that direction for the x. And if it's under the y, you're going for the y. Just remember this is a squared, so I had to do the square root first and b squared. Okay. So now let's get the rest of our values. Our vertices are longer guys here. And so this was me adding and subtracting 4, and it was to the x from the center. So you're going from the center. So you can either count over and you can go, okay, this is at -1, 3. Like you could do that. Or you could say I added 4 to my center, to my x value. So if I added 4, I'd get -1, 3. You can also get it from your graph. And then this guy is at -9 because I subtracted 4 from the x value. The b value this time is happening to the y value of the center. That's how we got the co-vertices. But again, you could just go over and see what they are. So I'm adding and subtracting 2 to the y value of the center. So if I added 2, I'd have -5, 5, which is that one. And I would subtract 2, which would give me -5. Once again, that's all right here. So if you graph it first, which is easiest, then you could even just get them from your picture. Okay, and then the foci should, again, be that relationship of a squared equals b squared plus c squared. A squared was 16, b squared was 4. So my c squared is 12, square root. You can simplify. This factors into 4 times 3, so 2 root 3, and you should do that. Okay. This is the c value, and remember c, c goes in the same direction that your vertices, your longer axis goes. So since I was happening to my x's, I'm also going to do this to the x value of the center. So that means I need to add and subtract 2 root 3 from the center. So the center is -5, 3, so I'm going to change the x value because I'm moving in the x direction. So it would be -5, what the x was, and then I'm going to add 2 root 3, keep the y value the same, and then I would also start at -5 but subtract 2 root 3. Again, the y value stays the same. So remember, your c value is going to go in the same direction as your a value. So if a changes the x value of the center to new values, then you're also changing the x for the foci. Okay? All right, now in this one, you're finding equations for the ellipses given information. And I said a sketch is going to be super helpful, so we'll do that. So remember, what do I need to write my ellipse? I need a center, and I need A and B, because then I can get my two denominators. Okay, so those are the things I'm thinking about. So my ellipse has a center at 13, -7. Hey, that's great. That's one of the things that I need. It has a major axis that's 30 units long. Remember, the major axis is made up of two A values, right? Because the major axis goes from vertex to vertex. So if the whole thing's 30, you know that A is just 15. That's important. You got to know that your major axis is 2A long so that you can get what A is. Okay. Okay, and we said that we have a co-vertex at 11, 1. Okay, this is where I would definitely, it also says what are the coordinates of the foci, but I also want the equation. So let's start with the graph, because this one is, we're going to need some help. Okay, so if this guy is over here at 13, -7. So here's my center. It says my major axis is 30 long, but I don't know right now if my major axis goes in the x or the y direction. So I'm going to hold off on my major axis. I do know that one of my co-vertices is at 11. That can't be right. This needs to change. Sorry, I think this one didn't get, I'll update this for you guys. 11, 7. I'm going to change that to 11, -7. So we'll be at 11, -7. So this will be a co-vertex. Well, first of all, if this is a co-vertex, guys, then remember, from center to co-vertex, that's the shorter one, so this has to be B. Remember, center to co-vertex is B, so that's B. So now we know B is, well, actually, sorry, we already have it over here. So B is, we now know the distance. How far is it from 11 to 13? Just 2. We also know that if this is the B direction, then my A direction has to be the vertical way. Do you see that? Because if this is the direction of the co-vertices, then the vertices have to be vertical. So we said our vertices are 15 units long. So if we wanted to sketch it, we could. We don't actually need to, guys. Remember, I said all we need is the center, A and B. So we have the center, we have A, and now you know the distance from C to co-vertex, which is B, is 2. You're ready to draw. You're ready to write the equation. I always start off with this, right? I have my blank squared plus blank squared equals 1. And then I'm going to use my center. So if my center is 13, I have x minus 13 squared. It's negative 7 for the y, so y plus 7 squared. A is 15, so I'm going to do 15 squared, and remember, that's happening in the vertical direction, so that should go under the y. So 15 squared, which is 225, would go under the y. And then B was 2, so 2 squared is 4. Okay. All right, and 8, find the equation of an ellipse with the length of the major axis. Hey, if you know major axis, you know A. A is 8. We need B, and we need the center. Okay. So they give you both foci. Remember, if you the foci are perfectly distanced away from the center. So if I were to graph this, -4, -2, and -4, +4, if these are both of the foci, then the center would be perfectly in between them, guys. So I need to find the midpoint. So remember, midpoint is when you add and divide by 2. So -4 plus -4 is -8 divided by 2, and then -2 plus 4 is 2 divided by 2, so we end up at -4, 1. Now let's see if that makes sense. -4, 1, yeah, that looks perfectly halfway between. So we had to find the perfect midpoint between the two foci. If I had both vertices, I could do that too. I could find the midpoint. If I had both co-vertices, I could do that. The center is always perfectly in between the 2 points, whether it's foci, vertices, or co-vertices. So again, if you're given both of 1, you can find the midpoint. Add and divide by 2. Okay, so I know my center. What's the only thing I need? B. Okay, well, we know A, and actually, if you know C, if you know the foci, you know C, because remember, C is the distance from the center to the focus. So how far was that? Let's see. The center is at -4, 1. So count up 2, 4. So we'd have to go up 1, 2, 3. So this would be a distance of 3. This is where the sketch really makes a difference, guys. Get a sketch. If this was at -4, 1, you'd have to go up 1, 2, 3 to get to -4, 4. So that means the distance from the center to the focus is 3. And now, if we have 2 of them, we can use that Pythagorean relationship. A squared equals b squared. You're going to keep using that. Like if you have A and you don't have B, but you can get C, then you can use A and C. So I've got 64, B squared plus C squared is 9. So I get 55 when I subtract 9. So B is the square root of 55. Okay, we got to finish plugging that into the equation though. So my equation, let's see what we got here. I've got my center now. So x plus 4 squared minus 1. Look, I'm getting at least a good chunk of the points here. I know A is 8, and I know, check it out, if your foci are moving vertically, remember your focal points and your vertex are always in the same direction. So if this is changing the y direction, then the y has to have the bigger denominator because it would also have the vertices. So foci and the vertices move in the same direction. So if you're trying to figure out who's A, if it's happening vertically, if you're moving vertically, changing the y, it should be under the y. So A squared would make this 64. And then B is the movement. We know that has to go in the x direction, and if I squared this, I would just get 55. So there we go. All right, last but not least, we've got vertices at, so, ooh, this time you have both vertices. So once again, if you have both of something, find the midpoint. I know it's going to be 4 because the 4 doesn't change, but then if I want to find the midpoint of 3 and 19, I'm going to add them and then divide by 2. So let's see, that's 22 divided by 2, so that's 11. So that means that my center is perfectly between the vertices at 4, 11. Again, if it were me, I would be doing a drawing. So 1, 2, 3, 4, 1, 2, 3. So there's my one vertex. And then 4, I'm going to run out of room. I'm going to scoot this down a little bit. Okay, because I have to go up to 19. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Whew, okay. So there's my other vertex. So again, I know that my center has to be perfectly halfway. I also know that my vertices are moving in the y direction, so y is going to have the bigger denominator, but I have to be perfectly in between. So perfectly in between 4, 3 and 4, 19 was 4, 11. So 3, 4, 5, 6, 7, 8, 9, 10, 11. And again, it should make sense. So once you sketch it, it should make sense. Like, is that middle? If you know a vertex and the center, you should also know A. So you just got to figure out how much is in between there. If this is 411 and this is 419, then the difference between these two is just a change of 8. You went up 8. So now we know A is 8. Okay. We also know a co-vertex. There's a co-vertex at 2, 11. So let's graph that. 2, 11. So there's my co-vertex. Remember, the distance between center and co-vertex is B, and so that distance is 1, 2. So B is 2. And remember, to write the equation, you only need center and A and B. So I don't need to find C, so I'm ready to go. I'm going to get it ready. Use my center, x minus 4 squared, y minus 11 squared. The larger direction is the y direction, so I'm going to put the larger value squared here and the smaller value squared here. Okay? All right, for the next two, we're going to use the graph of the ellipse to find the information. So first of all, we have to find the center. So we got to find the perfectly longest part. So the longest part I can see goes here, is the furthest it goes, and here. So I would draw that horizontal line, and then I would do the same thing here. Here, the furthest it goes here is there, and then the furthest it goes here is there. I can kind of see because it starts to round up. Okay, so then I would connect those two things. Once you connect those, you can just find their intersection. That's the center. So my center is 1, negative 3. Okay. Now they want the equation of the ellipse. Okay, well, we have the center, so we can get the equation started. X minus 1 squared, y plus 3 squared. Get that center in there correct. Switch the signs. Now we just have to figure out A and B. A is the longer direction, so now we're gonna have to count a little bit. So let's see, this went from 1 over to 11, so that length was 10. This went from negative 3 to 5, so that was 8. So we had the longer one is 10, the smaller one is 8, and the longer one is happening in the x direction. So those are the vertices, and these are the co-vertices. This is A, and this shorter distance is B. Okay. So now I should have my vertices. I mean, I could have gotten them anyway, but let's finish the equation. So that means the longer direction is in the x, so I'm going to make that the denominator, a squared, 100, b squared, 64. My vertices, I could use this to count over. This one is at 11, negative 3, and this vertex is at negative 9, negative 3. Now, my foci, remember, they happen in the same direction as your vertex, so they should be happening also in the x direction, but I got to solve for c. So I got to set up that relationship. A squared is 100. B squared is 64. I get, ooh, this one finally comes out nice. C equals 6. So that means I'm going to go 6 in each direction from the center in the x direction. Okay, so start at your center and go 6. So if I added 6 to the x, I get 7, negative 3. Remember, we're only moving in the x direction. You could also do it on the graph. 6 in this direction, 1, 2, 3, 4, 5, 6, puts me at negative 5, negative 3. You can do it right on the graph, guys. Either way, you'll get the right answer no matter what. So there's your foci. So once again, remember, your vertices, the longest distance, that major axis, also contains the foci. So you'll know which direction to move to do that. All right. Let's try another one. Oops. It's a little slow. Okay, so here we go. Same thing. I need to go my furthest. My furthest away vertically is here. And my furthest away horizontally is there. So my center appears to be at the graph is, the scale is a little funky. This is -2, so this is at -2, and then this is at 5. So this center is at -2. Careful. Each of these little boxes is not 1. It's like there's 1, there's, 2, there's 3. So you have to be careful with this. Okay. So let's do our equation. So first of all, we need to find the difference. We need to find these lengths. Let's see. This is -2. This is over here at 2. So from -2 to 2 would make this 4. Oops, I won't use pink. That would make this length 4. And then this appears to be longer. So let's see. This is at 5. So we went up 5 all the way up to, it looks like this would be 11. So that's 6. So once again, the longer one is A, so this is A, and this is B. Okay, let's write the equation. Let's start with our center. So our center is -2 for x, so +2 squared, and y -5 squared equals 1. My larger direction is the y direction, so that's going to be my larger denominator, a squared, so 36, and my b is 4, so 16. Major axis length, the length of the whole long major axis would be 6 plus 6, so 12. It's just 2a, remember, so 12. And the minor axis is 2b's, so 4 and 4, 8. To get your foci or your focal points, you need to do a squared equals b squared plus c squared. So let's see, we know a squared is 36, we know b squared is 16, we don't know c, so let's subtract, we get 20, square root, root 20 simplifies into root 4 and root 5, so 2 root 5. Now, which direction are we going to move to go C? The same as the long direction. So the long direction is happening in the Y, so you're going to move only from the center in the Y direction. So the X value of my center will stay the same. I should only be moving in the Y direction. So I'm going to start at 5, and then I'm going to add 2 root 5, and subtract 2 root 5. And so there are your two foci. Okay. That's ellipses. I would go back and watch them. You might even want to try the review again and then watch this again if you had trouble with it. Sometimes once you just get more comfortable with how the A's and the B's and the C's relate, you'll get more comfortable with doing these problems. But sketch, sketch, sketch. And the last one is the ratio one. Okay, A says find a point N on MP, so we're dealing with MP, such that M to N and N to P. So we are doing part to part. We're not doing like part to whole. So when we do part to part, we need to set up our first part, which is our 2, to the other part. But remember, we want to do the first part to the whole thing. So 2, if you add 2 and 1, you get 3. So remember, if you're trying to figure out how many parts there are to the whole, you have to add both parts of your ratio together. So I added 2 and 1 to get a total of 3. So that means I'm going to take 2/3 of the distance from M to the other end. So first thing I do is draw on my little triangle. So I'm going to draw my little triangle from M over to P. I need to figure out how long this side is. Okay, so that side's 12. You could do the other side, but you don't need it. You only need to do it from one side. And if we're starting with M, you need to start from the side that you connect to M. So since I went down and then across, I'm going to use this side. So I just need to multiply that side by 2/3, guys. That's it. I'm taking 2/3 of that side. So 2/3, 12 times 2/3 ends up giving me 8. So then I'm just going to go 8 in the direction of M towards P. So here we go. 1, 2, 3, 4, 5, 6, 7, 8. And then just follow it over. Bing. Now this part, and so we're going to plot it because they did say to plot it, and we need the coordinates. So N is at -3, -4. So one more time. Oops. How did I do it? first things first is I started by doing my first value, n, to the whole. The whole is this value plus this value, so 3. Then I drew in my little triangle, and I found how long it was for this side, and I multiplied that by my fraction, 2/3. So then I went 8, and then I went across. All right, let's try for QR. For QR, it says the ratio of QS to SR, and remember, we're going to do part to whole. QS and SR would be parts and parts, so the part is 1, the whole thing would be, add these two together, 4, so I'm going to need to go 1/4 of the way from Q, always start with your leftmost one, towards R. So I'm going to go Q to R, okay. So this side is 1, 2, 3, 4, 5, 6, 7, 8. I only need one side, so I'm just going to do this side. And so I just need to go 1/4 of the way, which is 2. So if I go over 2 in that direction, I just have to see where that hits the line. That would be S. So S ended up at 3, -4. Total coincidence that these were kind of close. Okay? Okay? You can review the ones in class. I also posted the notes. You can do this, but it might take a couple of times going through. Hopefully you remember the stuff that we did in class. Practice these ellipses. You can do this. This is not hard stuff. I know class went kind of quick, but now you have all night. You can watch me do this problem over and over, or you can watch me do, I mean, you're going to have ones exactly like 7, 8, and 9, guys. You're going to have to know how to do them. So make sure that you can do that. I would go through each problem. If you have to do it twice, like start it again, completely new, and see if you can do it, and then come back. This is your last quiz before the final. So, this is the last little push before the final exam. Okay? All right, good luck.